Remove the rotary seal components from the mutator shaft on both ends for inspection. The seal keeper O-ring is usually removed first to release the rotary seal assemblies from their positions on both ends of the mutator shaft. For the 2012 seal design, it's often easier to remove the rotating seal seat from the rotary seal body before removing the keeper O-ring. While wearing a protective glove, place the open end of the spring on the outside edge of the seal drive pin located on the mutator shaft. Unwind the wavy spring until the entire spring is free from the seal drive pin. Now that the rotary seals are removed from the mutator shaft, a careful examination of the rotary seal assemblies and wavy spring should be conducted before reassembly. All shaft surfaces should be smooth and clean, especially in the seal and bearing areas. The non-drive end bearing can be tested to fit on the stub end to make sure it can easily glide when reassembly takes place. Take special care to ensure that these areas of the shaft are not scratched or damaged. A bent or imbalanced shaft can cause premature bearing, seal, and blade wear, and may damage tube walls. Check the shafts annually for straightness and balance. The mutator shaft drive spline end should be inspected to ensure the splines are free of burrs and unusual buildup. The white bullet guide should be securely in position with Loctite on the bolt threads. If not, remove the white bullet by unscrewing from the drive end stub shaft. Notice the SPX flow part number is stamped on the end of the mutator shaft for easy identification. After removing the bullet, apply Loctite 243 to the bullet threads and then screw it back into the internal thread on the drive end of the mutator shaft. The non-driven end of the mutator shaft has a stub end with fine internal threads that are left-handed. With the shaft removed for general inspection, lightly apply anti-seize to the lock nut threads. The drive end shaft stub should be cleaned with a Scotch-Brite pad to remove any buildup, and then wiped with a rag to remove loosened debris. Thread into the internal threads on the non-drive end of the shaft. The lock nut should easily thread into the stub end during the installation process. If there is some unusual resistance, the threads may have a burr or some amount of cross-threading. If the lock nut cannot be fully threaded, a tap may be required to clean the left-handed threads for proper shaft lock nut engagement. Repeat the process of threading the lock nut into the newly dressed internal shaft threads to ensure proper threading is accomplished. Remove the lock nut before the non-drive end head is installed. The mutator shaft also has press-fit drive seal pins on both ends of the shaft that are important to the functionality of the seals. These pins must be present and possess the proper shape and height. The primary seal drive pins are 180 degrees apart and designed for the primary rotating seal body to turn within the mutator shaft. These primary seal drive pins must be round in shape and 5/32 plus or minus 15 thousandths of an inch tall, measured above the stub shaft surface. The secondary seal drive pins for the double mechanical option with one on each end of the mutator shaft should be 3/32 plus or minus 15 thousandths of an inch above the stub shaft surface. It is extremely important that these dimensions are maintained. If the pins are too high, the seal will jam. If they are too low, the body will rotate. Additionally, when the pins are missing or their shape becomes altered, they should be replaced immediately. Apply anti-seize compound on the male splines and the next 2 inches of the stub shaft before installing. Inspect the rotary seal faces to identify any defects that would impact the integrity of the seal once in operation. Additionally, inspect the stainless steel seal body for any damage or missing drive pins. Inspect, replace, and lightly lubricate the 2 O-rings in the inner and outer locations on the stainless steel seal body. The inner O-ring must be stretched to accurately fit the inner O-ring groove and maintain a proper seal on the shaft body. Finally, inspect the wavy spring and confirm the general shape is correct. Compare it to a new wavy spring to determine whether the height is correct. Over-compressed wavy springs will not create the necessary seal face pressure between the stationary and rotary components after reassembly, and thus may potentially leak. Reinstall the spring while wearing gloves to protect against sharp edges. Open the end of the spring and place it behind the seal drive pin located on the mutator shaft. Wind the wavy spring until the entire spring is behind the seal drive pin. Align the rotary seal with the 3 adjacent seal pins located on the perimeter of the rotary seal body and press into position over the outer seal body O-ring. For the one-piece seal design, the inner O-ring must be stretched, lightly lubricated, and fitted onto the seal body. With the rotary seal now ready for installation, slide it onto the mutator shaft for final positioning. Align the seal drive pins on the mutator shaft to the open notches of the rotary seal body and push the rotary seal body into position. Next, apply enough pressure to slightly compress the wavy spring and install the seal keeper O-ring into place. To ensure the seal is properly installed, grab the outer seal body assembly and rotate it to the right and left until the seal pins are touched. You will hear a knock as the pin comes into contact with the rotary seal body. Finally, push the seal body to ensure it moves freely with the wavy spring and with respect to the mutator shaft. Complete the rotary seal assembly on both ends of the mutator shaft. For the two-piece seal design, the seal body insert must be fitted with an O-ring on the inner diameter. This O-ring will need to be slightly stretched before it's positioned. Additionally, the seal body must be fitted with 2 O-rings. The outer seal body insert O-ring will need to be stretched and positioned in the outer edge of the seal insert groove. Next, the seal body insert is pushed firmly into position. Finally, the seal body inner ID O-ring must also be stretched and lightly lubricated before installing. Now that the two-piece rotary seal is ready for installation, slide it onto the mutator shaft for final positioning. Align the seal drive pins on the mutator shaft to the open notches of the rotary seal body and push the rotary seal body into position. Next, apply enough pressure to slightly compress the wavy spring and install the seal keeper O-ring into place. To ensure the seal is properly installed, grab the outer seal body assembly and rotate it to the right and left until the seal pins are touched. You will hear a knock as the pin comes into contact with the rotary seal body. Finally, push the seal body to ensure it moves freely with the wavy spring and with respect to the mutator shaft. Complete the rotary seal assembly on both ends of the mutator shaft. The rotary seal items that make up the double mechanical seal are commonly referred to as secondary components, which include a spring, seal body, seal face, and O-rings. The seal body should be inspected for general wear on the inside and outside diameters. The inner and outer O-ring should be inspected and replaced if burrs, cuts, or flattening is apparent. The secondary rotary seal insert face should be inspected and replaced if necessary. Lightly apply lubricant to the inner O-ring and insert it into the inside diameter of the secondary seal body groove. When this seal insert is replaced, the corresponding outer O-ring should be replaced to ensure a tight fit. The seal insert should not spin inside the secondary seal body during operation, so do not lubricate this O-ring. Insert the outer O-ring into the secondary seal body and press the seal insert evenly with both hands until it bottoms out. Just as with the wavy spring in the primary seal, the secondary wavy spring should be inspected for shape and size when compared to a new spring. Slide the spring into place over the secondary seal pin only after the primary seal has been reinstalled. It's a loose-fitting item due to the design. Finally, slide the secondary rotary seal body assembly onto the mutator shaft. Align the pin slot on this component with the secondary drive pin on the mutator shaft, and position the seal body assembly through the inside diameter of the secondary wavy spring. Complete the secondary rotary seal assembly on both ends of the mutator shaft. SPX Flow offers other blade styles that are application-specific and address various product and process conditions. The two basic types are closed and open. Closed blades are considered a standard blade and are solid without holes or cutouts. The open styles consist of either holes along the length of the blade or cutaways at the back edge around the blade pin slots. Blade materials range from stainless steel, brass, and plastic such as Celcon, PEEK, and metal detectable PEEK. The scraper blades are removed by lifting up and pulling them from the pins. Plastic blades with the locking feature should be lifted upward and then slid to the right before removing them from the blade pin. Reverse this procedure for reinstallation, and make sure the beveled edge is installed toward the shaft. The blade pen holders should be inspected for unusual wear on the pen tops and slots. Abrasions to the top of the blade pens could indicate contact with the tube wall, so there may be adjacent tube damage as well, and may indicate the shaft is bent. Blade pen slots should be round and uniform in shape, thus indicating the blades are free to float and move through each revolution of the shaft. Irregular shape or roundness to the blade pen slot indicates the blade tip pressures at the wall are high, thus exerting excessive forces through the blade and into the blade pin slot. Preventative measures on the process side should be addressed to minimize the tip pressures so that potential damage to the blade pins does not become widespread. A relieved blade with holes is often used for viscous product that would otherwise result in high amperage conditions with a closed style. The series of holes allows the product to flow through the blade, but still maintains its scraping action with reduced power requirements and high blade tip pressures. The cutaway style relieved blade helps prevent sticky or crystallizing products from building up on the blade and restricting its floating action in the universal blade pens. Restrictions caused by product buildup can cause excessive tube and blade wear, and in some cases cause severe damage. Note: keep the blades in the same position on the mutator shaft throughout the life of the blade. Make sure the blades are removed and installed in the same location on the shaft. A flat surface called the heel and a burr or feathered edge develops at the contact area on the side of the blade that is against the tube wall. The blades must be maintained to achieve maximum performance. When the heel of the universal blade, which is 2 inches wide by 6 inches long, reaches a maximum of 1/16 inch or 1.6 millimeters on metal blades, or 1/8 inch or 3.2 millimeters on plastic blades, they must be replaced or resharpened. Some of the 6-inch plastic blades have an SPX logo on the back edge that can be used as a minimum wear indicator. Resharpening these blades can occur up to the top edge of the SPX logo. For mutator shafts that are 4.5 inches in diameter or larger, the blade should not be sharpened to a blade width of less than 1 3/8 inches. For mutator shafts that are 4 inches in diameter, the blade should not be sharpened to a blade width of less than 1 1/2 inches. Stainless steel blades for the 5 1/4 inch mutator shafts are 1 9/16 by 23 29/32 of an inch. The minimum width after sharpening is 1 3/8 inch, and the sharpening angle is at a 15-degree angle. Worn blades reduce heat transfer efficiency and can cause excessive wear on the product tube walls. Blades can be subjected to challenging products and processes that not only wear the scraping edge but show evidence of warping, cracking, pen slot damage, or destruction. As the blades wear across the interior of the heat exchanger tube, they wear into the contour of the tube. Each blade should be inspected for wear and signs of fatigue or cracking at the blade pen location and should be replaced if damage has occurred. Failure to replace damaged blades may result in future breakage, which can damage other blades or the heat transfer tube and result in blade particles in the product. Additionally, unscraped portions of the product tube surface will reduce the thermal efficiency and may be difficult to clean with normal CIP procedures. Caution: high concentrations of acid or caustic should be avoided if plastic scraper blades are used. Cleaners should be compatible with the elastomers in the heat exchanger. To order genuine replacement parts or tools, contact your authorized SPX Flow sales representative or visit www.spxflow.com/WCB for more information.